Alright, I've literally written and rewritten this video so many times, and here's what I've determined. I've got too much to share. So I've kept in the parts that I think are most important and or things that people have specifically asked for. But if there's something that you want to know more about, drop me a comment below. I'll try to address it there, or I'll add it into a future video. I've avoided making videos like this for quite a long time, and I think the main reason is that I've spent thousands and thousands of hours and many mistakes getting to this point. And part of me kind of doesn't want to give it away. I kind of want to guard it and keep it safe. However, I also don't want to be a whingy old gatekeeper, and I wouldn't have got to the point where I am now if people hadn't have helped me along the way. So, if you do find this video helpful, please share it with a friend, drop me a comment, a like, a sub, as that's the best way to get more of these sort of videos, if that's what you want. Finally, just because I say it doesn't make it gospel. It doesn't mean it's the only way. It doesn't make it true, and it doesn't mean that I'm right. I'm just showing you part of the way that I approach problems like this. But I do have a degree in mechanical engineering, and I've been doing this for quite a long time. So take from that what you will. Anyway, you want a detail, you're gonna get it. Let's get to it.
I see them copy the same old sound, painted our lives. But could you tell me what it is that I'm missing? Oh, keep that mind tucked in your prison. These prisms swell. Yeah, or is it better if we overflow it? And birth codes, young king set to overthrow it. Spread wings like where RD was just a scribble on some dotted paper. You hear things, now we major, huh? Long removed from the youth that I remember.
In the last video, I had quite a few people asking me about a bit more detail in the design process. Like I said in the earlier video, I wasn't happy with the effort I put into V1 of the switch panel, so I started again, and the design idea became OEM Plus. I want the switch panel to look like it could have been an optional extra in 1974. So, what are our design considerations? You'll note this bezel in detail around the heater controls is pretty prominent and also present on the radio section as well. So I'm going to take this as my inspiration for the outline or the border. The factory dash has these little knobs to adjust the heater controls, and so I thought I'd use them as inspiration for the new custom ones. I really like the vibe of a 70s and 80s Ferrari, Di Tommaso, etc. and the chunky style switches. I imagine them having a nice solid clunk when you throw them, so I think I'd like to make an enlarged style switch inspired by these ones. I would also like the name of what I'm switching to be present, as well as an indicator light, so I combined the two, but I also want the text to be large enough to be read comfortably. So that basically gives us our minimum bound for the design. Finally, I've got these old school Amori gauges that I want to incorporate, and given space restrictions, I decided on 2 gauges off to the side, which leaves us this space above the heater controls, which, given the other limitations I mentioned earlier, will divide nicely into 4. Cool. Now we've got a rough idea of layout, we need to think about packaging and manufacturing/assembly. So we've got these things to think about. Dash mounting points. The OE dash is a steel bracket with a plastic face. At this stage I'm not sure if I'm going to replicate that, but my initial thought is that I ideally wouldn't, and I'd just make the mounting points from the 3D print. Something else that I see people commonly do would be to modify the OEM part with their custom design. There's a few reasons that I don't like this. One is that if I ever wanted to make more, I'd have to get more OE fascias, and Toyota isn't exactly making new ones anymore. 2 is it can be difficult to be repeatable, and depending on the design it may introduce new limitations. But most of all, permanently modifying the vehicle is one of my last resorts. I like the idea of being able to return the car to stock if I ever wanted to, and as much as possible to be able to preserve the originality of non-replaceable parts. We could obviously argue specifics at this point, but you get the idea. If I don't have to do it, I'll try not to. Back to things to think about, I'd like the gauges to be slightly angled to the driver, and therefore, depending on the depth, they may exceed the envelope of this area and interfere with the frame of the dash. Not only that, we can see that mine has been somewhat unceremoniously cut to wedge an aftermarket head unit in there, so I want to make sure I don't make my design wider than the standard area, as then it wouldn't work in another car with a factory dash that hasn't been cut. The heater controls actually mount to the steel frame, and if I don't replicate/include a steel frame with my design, the plastic design needs to be strong enough and also provide some form of mounting solution as well. Finally, we need to determine what I'm at least initially thinking about manufacture. Likely it'll be a combination of resin and FDM printing. Great, we're getting an idea here. Now what are the 4 switches going to control? I also have the need for a few more switches to control some other things in the future, but they're going to be mounted elsewhere. Okay, so what requirements do the 4 things I'm going to be switching have? Well, the KE25 actually uses no relays from the factory. As a result, switches are known to suffer from burnout, particularly things with high load like the headlight switch, and they also use these dodgy little glass fuses. So in the perfect world, the whole car would get a rewire, but let's not become a victim of scope creep. Therefore, I'm thinking a relay box that feeds from the switch panel and to the components. So regardless of the physical reality of these systems, they do also have some minimum requirements for wiring that will have to be satisfied no matter what. So let's start there. So what are our thoughts here? We want the switch panel to be compact, we want the indicator lights, efficient wiring, and for the thermofan we want 2 switching options. This will require running switches on the ground side, however the latching loop for the 2-step requires wiring a switch on the positive side. So that means no matter what, we're going to need to run positive and negative wiring to our switch panel. Don't worry if that's gone over your head, I'll get to that. Also, I don't want to forget this loop here, because if one or both of the lamps blow, I still want the circuit to be functional. We've also now determined that we're going to need at least 6 wires here, 1 for each switch and 1 each for positive 12 volt and ground. I could, in theory, run a ground wire straight from the unit to somewhere nearby on the chassis, but I think that'll look messy. I'd like it all to be nice and tidy with just the one connector. So how are we going to wire it? I'd like the switch to be standalone, so we're going to put a plug in here. I could make it with a loose tail, but I think I would like it to be recessed into the unit and all nice and self-contained. As we've determined we need 6 wires, for now I've decided on this 6-pin Deutsch style plug. There is temptation here to just get stuck into the switch panel design, but we don't know what we don't know. And I'm a mechanical engineer, not an electrical engineer, or an auto electrician. So let's finish our electrical plan and also run a bench test to make sure everything's going to work as we intend it to. This is another one of those times where I wouldn't normally share something that's unfinished, but consider this a work in progress. This is my initial plan for the wiring diagram for the system, and once I've completed it, I'll likely have this available on my website, as well as plans for wiring each system individually. Standard, I take no responsibility for your actions or your vehicle, do with this information what you wish, at your own discretion, applies. Something else to note now is that I will likely move the battery to the boot in the future in a similar fashion to what I did with the KE70. There he is. That'll give me just a very slight one on this edge here, and I set the height so that finish cleaning these up, and I'm going to just try and put it in there, and I can drop this down. And there we go. This is for a few reasons: more space in the engine bay, more weight from the nose of the car to the rear, and also just to generally tidy things up. Why is this important? Well, that will move the power source from the front of the car to the rear. So I need to ensure that whatever I make is flexible enough that changing the setup won't affect what I'm making now in the future. Here's where I must interrupt our progress, as the L320 decided to start leaking power steering fluid. The Guitar Hero episode of South Park, you haven't seen that?
No.
Oh my god, that's another classic.
Check this out. Oh, I love this song.
And luckily, there's nothing Angelo would rather do more on a Saturday morning than work on my car.
I'm pretty tempted to cut these. Holy shit.
And obviously I was doing all the hard work.
Someone's had a go at this.
Oh man, they taped it up. They do a good job.
No.
Turns out, for reasons unknown, the power steering line decided to migrate over and become friends with the thermofan, and believe it or not, cars that weigh over 2.5 tonnes receive some benefit from functioning power steering systems. But all things considered, it actually was one of those jobs that should have only taken an hour, and in fact only took an hour. I guess it's a Christmas miracle. Thanks, Santa. I mean, Angelo. Okay, specifics. Let's talk about switches. So I've been talking a lot already about packaging, and being that we're running an external relay setup, there's no reason we can't run some nice, small and compact switches here. However, these ones just don't have that sound and feeling I want. So I got these ones. Cool, how are we going to integrate this? I like to make a CAD model. Does it need to be as detailed as this? Absolutely not, and I don't always do them to this level of detail, but I do like to. Another positive thing of having the detail in this is that I know that if I come back to this months or even years later, the model is accurate and there's nothing I need to remember that I left off the model. Yes, I am aware of websites like GrabCAD and similar. If you want to use them, more power to you. Sometimes I do it too for things I don't have immediate access to, but I prefer to make my own models where possible. Also, if you want to get good at something, you should practice it. If you want to know how other people make things and manufacturing considerations, etc., you need to put in the work. I cannot stress this enough. Alright, cool. We've got our switch. My first thought is about how I'm going to cover it with my inspired switch design, so I'll sketch that over the top. And now we need to think about the pivot point of both my cover and the switch itself. If the pivot points are not the same, or at the very least close, the cover is either going to be too tight to work or too loose to work. We also need to make sure that there's enough clearance inside the mounting hole, again, otherwise it will get stuck or it'll be sloppy on the switch and it won't feel nice to use. Ryan, you said you were going to give us more detail, then that switch just came out of nowhere. How do I model that? Firstly, get yourself a pair of these. This is a vernier caliper and you don't need an expensive pair to start. This is a pair from Supercheap and they were under 25 Australian dollars. Yes, you can get digital ones, but I don't like them. If for no other reason than the time that you really need them is always the time that the battery is dead. Now this is one of those things that I'm going to summarize because this is practically a course in itself. You should model ideally around a central datum. In this case, I'll use the mounting thread which is central to the switch, then break it down into pieces. The thread is a cylinder, the body is a rectangle, as are the connection tabs, and the switch lever itself is a tapered cylinder. Okay, then what? Measure it, model it, check it, make mistakes, and keep trying. Practice, practice, practice.
It's easy to sum it up. Practice, 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 man.
Well, the switches are designed to secure over this threaded section here, so we'll stick with that, and then we've got the cover. It makes the most sense to mount on the axis of the pivot point, so we'll do that too. A little extra design consideration here. I'm going to put a little boss on the pocket and a little recess on the switch. This achieves a few things. It takes the pressure off the pin that I put in here for if and when people push on the switch as opposed to just flipping it. It gives more of a positive positioning of the switch cover and something for it to rotate comfortably about. Therefore, not all of the pressure and function is relying on the pin now, and so it helps ensure smooth use over time and helps prevent excessive wear of the pin joint. Cool, now I want to think about how far the switch actually protrudes past the front face of the dash. I want them to be protruding because of the tight space here. I can already see that if they don't, they're going to hit the bottom of the pocket and it's going to be hard to get a finger underneath. That said, I don't want them sticking out too far because then they could be too easy to accidentally knock when going for one of the other switches. None of these are particularly critical though. There's no ejecto-cedos here. Just a note while we're here, some of this process is done quite quickly, possibly in my head or as a quick little sketch. And it's often a combination of CAD drawings, CAD models, and or pen and pencil drawings. Regardless of the exact process, you get the idea, the same concept applies. There's a lot of back and forth with the design to get to this point, but I'm ready now to make a print and test the changes. So let's go over them. Firstly, you can see I've thickened up the body a lot from the previous prints. And you might be wondering why I made them so thin in the first place. This is for a few reasons. Less material on the part means it's faster to print. With it being completely flat on the back, it means I don't need support material, and most obviously, less material means less waste, means cheaper. That's why I separated the heater control portion here, but then I needed to attach it to test it. For a prototype, this is fine, but you can see that as a final product, there's very little strength here, and it wouldn't take much for it to break. So if I still plan to print in separate pieces, how am I going to securely attach the parts? Again, there are multiple solutions to this problem, and for now, I've chosen heat certs, which are essentially a metal thread that you melt into your chosen part. I'll cover these in further detail later, but for now, here's my model. You may not have gotten much from my earlier sketch of the plug being a part of the housing, but here's what I was thinking. It's still removable, and it's located on its sides by the main body, then held in place by the lid when attached. Moving on to the indicator lights, hopefully now you have a better idea of what I was thinking earlier, and you can see how this initial sketch is now turned into something ready for testing. The lamps will all be mounted on a single strip of perf board, secured with some M3 screws, and I'll be using incandescent lights rather than LEDs. There's a couple of reasons for this, mostly being that I don't really like the harshness of LEDs, dimmed or not, but also because I want to match the type of light that we're going to get from the pre-existing lamps in the dash. You've probably also noticed that the lamps in the OEM dash are clear, meaning that the translucent green colour is coming from the dash itself, while I've modelled both a green cover for the lamps as well as a translucent section as well. This is mostly for aesthetics in the CAD model, and the finals will be clear rather than the green as you see here. These are the little sleeves that I'll be using for the coloured indicator, and I may use some of the other colours in the future as well. Finally, part of the redesign meant a change to these mounting points, which are now also secured with M3 screws. Now it's time to prepare the mounting board for the indicator lamps. I've gone with perf board here. I could have also used green board or a PCB, which I will concede looks nicer, but it's not as easy to cut to shape. Besides, the amber brown of the phenolic resin is giving me 70s 80s vibes anyway. Another reason why it's advantageous to put the effort in with the early stages of design is we can create accurate drawings quickly and easily. This is just a draft, so don't come at me with AS 1100 standards. I practically know these dimensions off by heart now anyway. I just need the width and height, which is in millimeters for those of you playing at home. Something I like to do when using a tape or ruler for measurements like this is rather than using the very end, I jump up to the next whole number and measure from there. So we're going to measure from 120 millimeters to 10 millimeters rather than 110 to 0. Now I've never actually cut perf board before, but I'm led to believe it should be pretty easy to just score with a blade and snap off. I'm resisting the temptation to cut with something else, and I figure it'll be pretty easy to dress the edges if I need to. Also, everything in me is telling me not to cut on this bench because I don't have a proper cutting mat beneath it, but I'm gonna. If I was smart, I would have done this edge first, because now it's going to be much harder to hold on to this. Should clean up pretty good. What's that saying? Do as I say, not as I do. Don't do this. Do this one. Also, those among you who aren't watching this at 5 AM might realise that I forgot the hole dimensions on the drawing. Luckily I know they're 3.5mm. I'm sure you know how a drill works, so I'm going to drill them off camera. And in the meantime, let's prep a couple of the lamps for testing our circuits, using the perf board offcuts. Waste not, want not. In the spirit of explaining how things work, I thought this might be a good opportunity to actually show what a relay is and how it works. It is, essentially, just an electromagnet, but let's see how they really tick. I also hear they taste good with fava beans.
Hello, Clarice.
Cool, huh? This is a 5-pin relay, and without complicating things right now, just know that the function is identical to a 4-pin relay, except we have the option of alternating power to another circuit. Stay with me, I promise it's very simple. Let's mark out the points here and I'll explain what each of the wires are doing. Consider this direct power from the battery. Regardless of whether the car is on or off, as long as the battery is connected, there's power here. Depending on what we're looking to power, we should add a fuse to this wire. The size of the fuse will depend on what we're powering. A common rule of thumb for this is that our fuse should be 1.25 times the amp draw of our item. So for example, in the case of the thermofan I have, it's rated at less than or equal to 7.5 amps, so multiplied by 1.25, that means we should use a fuse rated to 9.375 amps.
Or $11.395 million. Jordan fades back, swoosh, and that's the game!
We probably should round down, but in this case, I'm sure a 10 amp fuse will be fine. As I said, this wire is constantly powered, but we don't want our item to be constantly powered, so we need some sort of switch. In this case, we'll consider these coloured lamps our item, and regardless of what we'd chosen, they'd then need to be run to ground afterwards. You saw me mention earlier about the KE25 having no relays, and the power just running through the switches. Why is that bad? Well, basically, not all switches are rated to have such large currents pass through them. We want nice little switches in our dash, not big ones like this. So by using a relay, we can get our power to our item safely. The relay only requires a very low load to switch between supplying or not supplying power, and that's what this switch does. It activates the relay, and it must also be run to ground. Alright, so what's this normally open, normally closed business? Let's first take half a step back. I said this was a 5-pin relay, but what's the difference to a 4-pin relay? Simply, it just means either of these pins here have power. As we switch between them, you can see this little flap or armature makes contact with one or the other pin, and as such, either our red or our green lamp has power. We can make a 5-pin relay function like a 4-pin relay by simply not wiring anything to the 5th pin. It's marked here as 87A or normally closed. So we just get rid of our circuit with the green light here, and therefore power would only be supplied by this relay when we flip our switch. I've also put a couple of diagrams up on my website showing both a positively and negatively switched 4-pin relay, and I'll add to these in the future. While you're there, maybe check out some other stuff I have available as well. Links in the bio, and I ship worldwide. But Ryan, I want even more detail. Why does sending power to that coil cause the bar to move? Well, that copper coil you see there is called an electromagnet. The copper wire is wound many times around, usually, an iron core. And as such, a magnetic field is produced when an electric current is passed through the copper wire. When power is no longer supplied to the coil, the magnetic field disappears, and this concept is usually what was used for those really old school bells, and is in fact also the same concept that was used for original tattoo machines, which I actually started making one of a while ago. Here's one of my initial prototypes. Do you see what I mean about too much detail? I will literally go on forever. But if that's what you want, let me know. Otherwise, let's get back to it. Now it's time to finally check out the prototypes that I've printed. As I mentioned earlier, these are just printed from PLA. It's cheap and easy to print with, and it's actually also quite strong. And my initial thoughts on the design now that I'm able to hold it in my hands is that overall I'm pretty happy with the direction that it's heading. Although somehow I managed to print this main body here with support structure not selected in the slicer, and considering that, it's actually come out amazingly well. Just a couple of little rough spots. Now let's talk about heat certs again. These are little brass bodies with threads on the inside and some burrs on the outside to help prevent them from twisting while in use. You create a hole in your part to suit the outer body, and then heat them up to melt them in there. As you can see, they come in all different sizes and threads, and there are different sized heated tips to suit. Let's get the soldering iron sorted and test them out. I print this particular PLA at around 215 degrees C, but I'm going to initially set the iron to a lower temperature and see how that goes. We can always turn it up later. Wow, I've got to say that actually looks pretty snazzy. The front face portion is mainly to hold the indicator light labels, which I haven't got to put in there just yet, but I think it's going to work perfectly. We'll test out a couple more heat certs, and here's one of our first lessons about why mechanics and practical people hate engineers. This looked perfect in CAD, but we've got a bit of an issue getting the soldering iron in here. It's not actually a huge issue in this case, as it won't cause the thread to be too off center, but that would have been a possibility, as well as possibly not even fitting in the iron at all. Anyway, they're looking pretty good now, and it's time to trial fit our perf board and a couple of switches in there. And now we're on to our next issue, this little guy. You can see we measured everything perfectly, and this connector is perfectly snug in there, but now we can't get it past that lip. Also, we can just squeeze each of these connector types onto the switches, but how are we going to get to the bottom ones? And so this shows you another CAD trap, trying to make everything too snug. There's no reason I can't make this area in here larger. There's plenty of space inside the dash, and it'll not only allow me more room to work, but also allow me to sort out some nice cable management as well. Let's at least put some more heat certs in before swapping the iron back to a soldering iron tip. Another thing we've done is gotten a bit too carried away with the amount of heat certs. We can probably drop both of these pieces down to 2 each rather than the 4. Let's stop for a second and also talk about heat certs versus just tapping the part. There's actually nothing wrong with tapping a 3D print. I do it all the time. In fact, I've sold hundreds of different variations of simulator adapters over the years, and they're all tapped. And I've been using the exact same one on my sim for over 5 years, and each and every one of them is tapped. Again, to prevent this from being lengthy, I'll summarize. Even if you had a bottoming tap, which is generally not ideal, it's preferable to not tap into a blind hole, i.e. one that doesn't go all the way through. And if the thread is going to see a lot of use, you probably would want the heat cert. You can also print threads like this bad boy here, but basically the smaller the thread, the less suitable for printing. Anyway, let's get these lamps soldered in ready for testing. For now, I'm going to wire them in series. I may change to parallel in the future, but we'll see how bright these are first. And I'm going to cover more of this when I cover wiring in the next video. And I reckon that's looking pretty good. So some of these issues we've gone over were probably more obvious than others, and you may have picked up on some of them earlier in the video, or maybe not. Again, this is why it's good to test things as you go, before you run off and commit to a design and possibly pay for a bunch of manufacturing, only to realize your errors when it's too late. It's really what 3D printing is perfect for: fail fast and fail often. It will get you to a better solution quicker. So this video actually took ages to get together and cover everything. I reckon in the time it took me to make this, I could have practically finished the car. We've still got lots to go over in the next one. I'm going to cover different materials for printing, as well as FDM and resin printing, making the changes that we've already discussed, as well as quite a few that we haven't, 3D printing processes, wiring, and whatever else strikes my mood at the time, to be honest. Again, if there's something you want to see more of or something that I haven't yet covered, let me know in the comments and I'll add it to my list. Again, thank you for watching. I'll see you in the next one.
And they virgins observe the pressure put in our seeds to get straight A's. I know I was rushing home just to get straight blaze. You know the age, naivety, frustration, and rage. Suicide rates constantly raised, and I'm amazed. Graduate and maybe you can work the rest of your life. Education for some dreams and aspirations aside, y'all get the picture. These kids are falling victim to a system, raising money hungry in a food scarce prison. And when that prison is the building blocks for a whole generation, it takes someone great to instigate some separation, know what I'm saying? So stand alone, fucking stand tall, dog. You can always get up higher than you fall, dog.